Hello good people, I'm going to talk about covalent bond polarity. So what is polarity? Polarity is a result of unequal sharing of bonding electrons due to the electronegativity difference. I'm going to use two examples to hopefully demonstrate. I'm going to start with hydrogen fluoride. Fluorine has a higher electronegativity value. This means that it will pull on the bonding electrons more. I'm going to represent that in terms of the electron cloud. I could say that because fluorine pulls on the electrons more, electrons are spending more time around fluorine than they are around the hydrogen. And as a result, the electron cloud around fluorine is bigger. Now, considering that the electrons carry a negative charge, I could say that the fluorine side is a little bit negative, because the negative charges, the electrons, are spending most of their time there. And so in chemistry, we say that the fluorine side is partially negative. We indicate it by a special symbol. It is the lowercase Greek letter delta, which looks like this, and then we place a minus. So fluorine is partially negative. Relative to the fluorine, I could say that the hydrogen side is partially positive. This molecule, in terms of partial charges, has two different poles, a positive pole and a negative pole. This can be indicated by a dipole arrow, and it looks something like this. Here's my arrow, and the head points towards the negative side, while the tail is at the positive side. Using the language of chemistry, we say that the bond between hydrogen and fluorine has a dipole moment. Or we simply say that the bond is polar. Let me bring in another example. This time I'm going to look at a molecule of hydrogen. Because the atoms are identical, there is no difference in electronegativity. In terms of the electron cloud, I could say that it is evenly distributed across the bond. And so, I cannot draw a dipole arrow. This also means that there is no dipole moment. And if there is no dipole moment, the bond is non-polar. Strictly speaking, whenever there is a difference in electronegativity values, we have a polar bond. However, if the electronegativity difference is very small, we tend to consider the bond non-polar. And so there is a guideline. If the electronegativity difference is greater than 0.4, we consider the bond polar. On the other hand, if the electronegativity difference is less than 0.4, we consider the bond non-polar. Please note, this is not a hard and fast rule. It is a guideline. That is all for now, and I will see you on the flip side.